All right. Well, welcome everybody to the highly anticipated Niznick's penalty shots. Dr. Gerald Niznick joins us tonight with his responses to the marketing claims that we heard during the Implant Faceoff. You know, the marketing claims and the personal experience that those clinicians had with the implant systems that they represented. It was a great success. It was very great to have all those fantastic clinicians share their experiences and their successes with their preferred implant systems. But tonight we're going to have the one and the only Dr. Gerald Niznick, the godfather of implant dentistry, if you will, give his feedback and his insights to not just what they had to say, but also some of the innovations that he has patented throughout the years and the great innovations that he has coming out through his Paragon implant company. So Dr. Niznick, first and foremost, I just want to thank you for being here.
Thank you. Great to be with you.
So Dr. Niznick is in the driver's seat. So you're going to see me wave my hand. And that's just my signal to Dr. Niznick to progress on to the next slide. So I just want to introduce myself. I'm Dr. Brandon Kofford. I am the founder of Smart on X, the company that introduced the product Smart Denture Conversions. And this slide kind of got messed up in the transfer from PowerPoint to Keynote. And so I'm just going to move right along. Dr. Niznick, if you could advance. So I want to introduce Dr. Niznick tonight, which he really doesn't need much of an introduction. So actually, let me just review this. Smart on X was formerly known as Smart Denture Conversions. And then when we expanded the product line, we rebranded to Smart on X so that it would incorporate the Smart Denture Conversions product, our Rapid Arches product, our Omnibutt product, and our Simple Temp product. And you can find all of those at smartonx.com. But now, if we just do a little bit of housekeeping, this webinar is being recorded. It will be available on demand and sent to all registrants. So do not submit questions in the chat. We want you to please submit all questions in the Q&A section. And then at the end, we will find the questions most relevant to Dr. Niznick's presentation and have Dr. Niznick respond to those questions directly. Dr. Niznick, if you'll advance. All right. Smart on X is not responsible for any of the content today. This is all Dr. Niznick. He owns this content. He fully accepts responsibility for this. Before we got started, he told me that he was one of the most hated people in dentistry. And I don't know that that's true, but there's a lot of jealousy over Dr. Niznick's great success and the fact that he has been able to be out of the mouth for as many decades as he has been able to because of the great success he's had in innovating implant systems. So we're really grateful to have him. And let's go on to the next slide. All right.
Okay, this is where I start?
Yeah, but just let me give your background, Dr. Niznick.
Hey, pardon?
I'm just going to introduce you a little bit, and then you can go right into your presentation. All right, Dr. Niznick is the founder and industry leader in implant dentistry. He founded and served as president of Kofford Dental Implant Company from 1982 to 2001. Later, Paragon Implant Company. He sold the business to Sutzer Medica, later the Zimmer Dental, in 2001 while retaining his dedicated implant manufacturing facility in Calabasas, California. Then he established Implant Direct LLC in 2004 and launched its product line in 2006, introducing compatible implant systems, all-in-one packaging, and a direct-to-dentist sales model that created the implant industry's value segment. He developed the first fully automated lights-out 24/7 implant manufacturing facility and sold application-specific implants online at disruptive pricing while maintaining high precision and quality. He sold 75% of Implant Direct to Cybron, or Danaher, in 2010, forming Implant Direct Cybron. remained president until 2013 and later a consultant through 2017 after selling his remaining ownership. As far as his education goes, he was a graduate of the University of Manitoba in 1966 with postgraduate prosthodontics training at USC and a master's in prosthodontics from Indiana University. He's trained over 10,000 dentists worldwide and earned 33 US patents in implant dentistry. He's a recipient of honorary doctorates from the University of Manitoba and Tel Aviv University, the American Academy of Implant Dentistry's Isa Liu Research Award, and a VA commendation for funding a major multi-center implant study involving 900 patients and 2,800 more implants, with results published in leading dental journals. So this is a guy who's got a lot of context in the world of implant dentistry, and he has lived the history. So Dr. Niznick, without any further ado, please take your penalty shots.
Thank you. Thank you, Dr. Kofford. Of all the introductions I've ever had, that certainly is the most recent. Okay. This presentation will analyze the claims made by 8 implant companies to help dentists differentiate marketing claims from clinical reality. I will contrast the design features claimed to be critical by the KOLs with those incorporated into Paragon implant system, with the goal of helping dentists determine the best option for their practice and their patients. It's not my intent to take any shots or criticism of the clinicians themselves, because I think as good KOLs, they're just repeating what the company's marketing claims are. So we're going to be looking at the marketing claims and how they hold up. My comments are based on 55 years of experience placing, restoring, designing, and manufacturing dental implants. I've accumulated 35 dental implant related patents in the 44 years of evolution from the hollow basket Kofford through Paragon, and there's 3 more patents pending. This image shows the different generations of products that I've had. Generation 1 being the Kofford, the hollow basket, which in the 1980s was really the competition to the Nobel implant. In 1986, I introduced the screw vent with the first internal conical connection. It's got a 45-degree lead-in bevel, internal hex. Some people think that that's not a conical connection, that it needs to be 74 degrees or whatever. But if you look up a definition of a conical connection, it's a cone. And I'll explain how the 45 and the 78 and the 83 all work the same way, give the same benefit. Generation 3 in 1999 was the tapered screw vent. In 2000, that was bought by the precursor of what is today's ZimV. That implant 27 years ago is still on the market today, highly successful, highly used. They've made a few modifications that probably take away from the advantage of the original one, but we'll talk about that. In 2004, I sold Kofford in 2000, and then in 2004, I started Implant Direct with a variety of different implants. And in 2022, when my patent, when my non-compete had expired, I launched Paragon. 3.5 years in product development until we got FDA approval about 3 months ago, and we're ready to rock and roll. Now, during those 45 years of commercial competition, I have repeatedly spoken out on controversies in science and the role of the industry. Implant sales depends on companies' unique selling proposition. That means that whatever features differentiate their product from the competition needs to be positioned as the most significant feature for clinical success. whether it is or not. I've often said you can put peanut butter on an implant, and if you got the right KOLs out there touting it, you could sell it. I've spent my entire implant manufacturing career differentiating market rhetoric from scientific and clinical facts, starting in 1984 when Nobel sent an open letter criticizing me for quoting their published research. They thought that was their proprietary information. And then throughout the years, I've published documents and letters. 89 was taking a hard look at pure titanium versus alloy, osseointegration, surgical protocols. In 98, I wrote this controversies booklet on implant connections and surfaces, and again in 2004 on connections. So these are available on Paragon's implant website if you want to read the details. Dr. Leroy Horton is in an interview asked me why, after building and selling 3 successful implant companies, did I decide to launch my 4th. I thought the question was very intuitive, and I want to share with you the answer.
But my question for you is, for all these years, are you driven by the desire to create the perfect implant? Or is it more a primal need to stay dominant in this space of ours in the industry? What would you say is your motivating force for still going?
I think it's just the stupidity that's out there. Right? Irritates the hell out of me. And what's happened in the implant industry is a company comes up with a design, a Straumann or a Nobel, and they make it popular. Then you've got all these clones, 25 companies from Israel, Brazil, Korea. Well, they think I'm just going to copy that, and I'll sell it for less and make some money. And so all the implants gravitate to the wrong, what I believe is the wrong direction. And I just felt I had to come back and do a reset.
So the clinical success of my Gen 3 tapered screw vent, still sold by ZimV, and the Gen 4 legacy from Implant Direct are the model for my new Gen 5 implant, Paragon implant. The body and the threads of the legacy are the same as, and the surface is the same as the Gen 5. What changed was I replaced micro threads with a 2mm smooth neck. Studies that report high survival rates do not tell the whole story of implant success. ZimV has on its website 14 clinical studies documenting 99.3% survival, 10-year survival with the tapered screw vent. But it's talking about survival. It doesn't talk about complications. This is a published study on the Gen 4, the legacy implant from Dr. Cavallero with 100% success. And if you pick your cases right, and if you know what you're doing, and you can get a very high success rate, no doubt. But also, there's no doubt that there's a lot of complications. Bone loss, peri-implantitis, loose screws, and fractures occur with time. This literature review covered 16 years of implant performance. 5-year implant survival of dental implants was 94 to 95%, and 16-year was 83%. But there was biological complications reported at 17%, and technical or mechanical complications at 31%, for a total of 48% by 16 years had some level of complication. The idea is to minimize that in the design of the implant. To minimize biological complications, implant design should include a long, smooth neck to accommodate bone remodeling without exposing the blasted surface or the threads to the soft tissue. To minimize mechanical complications, the implant design should use the strongest material, that's 6Al4V, titanium alloy, 34% stronger than grade 4, which is used by many companies, have an adequate wall thicknesses. And when you go with a long conical connection, you thin out those walls a little bit. And you need a very stable implant abutment connection. A lot of that has to do with the precision manufacturing. Are you buying an implant from one place and buying an aftermarket abutment from somebody else? All these can affect the mechanical problems. Technical complications include screw loosening and fracture. Fractures of both implant and abutment are well documented. So this was the 1987 patent, filed in 80, developed in 86, filed in 87, is issued in 1990 on the internal conical connection or internal bevel connection. This did not specify which angle the bevel is. I chose 45 degrees because it left the wall thicker. It had a shorter hex, so I could make shorter implants. But this patent covers the long bevel, the 78-degree bevel of Nobel Active, for instance. They couldn't sell in the United States till 88 into 2008 when this implant patent expired. So Implant Direct still makes the 45-degree bevel and the 78-degree bevel that's compatible with Nobel Biocare's products. Astra has a very long bevel and thus very thin walls. And fractures have been reported with this implant. Here you see one. This little piece of metal right here is what fractured off the implant. And there you can see the broken implant and the implant. Move this thing here, and the broken implant down at the bottom there. I wonder if I can get rid of this. No, there, okay, partly. Look at this case. Came into the dentist that rents space from me in Las Vegas. A Clear Choice Neodent case. The distal implant lost integration. That overloaded the anterior abutments and they all snapped off. And the dentist ended up taking out all these implants and replacing them. So these are major complications caused by lack of integration or just weak material. Look at how thin these distal abutments are. This system has one connection for all 7 diameter implants. So when you use a wide implant, you still have the weakest possible connection, and you could anticipate fractures if one of these implants lost integration. There's no question there's complications. There's symposiums on complications. Here's one: complications in implant dentistry, avoidance, prevention, and management. This is full arch complications, PICO's symposium. And then here's a zygomatic complication program. You might say this is a complication. These are long, straight implants, most likely the neodents, because that's the shape of their implant, and they use long implants. And the implant came out with the bridge. Why we should not only focus on treatment, we need to focus on how to prevent the failures. An ounce of prevention is worth a pound of cure. So this video shows plaque that's accumulating on the implant. I'm not sure what device this is to remove it, but it's doing a pretty good job. But now he's going to go subgingival and clean it off of the implant. So look at the implant thread that's exposed. That will probably be ground off. It would be so much easier if the implant, and this is the Gen 5 implant, if the implant had a 2 mm smooth neck. That plaque and biofilm would probably not form to the level, and this is how you minimize peri-implantitis.
Look at the disease model, then there is a tendency for all of us as professionals, but also for lay people out in the community, the public, to attribute the risk factors predominantly to the patient because it's the disease. If we then flip it and say, what if we look at it as a complication, as a complication model? Now, the minute you look at and frame something as a complication, the risk factors then have to be attributed much more broadly, which includes the patient, of course, but it includes the device, as an orthopedic device, the technique, and the clinician. So this is the natural way we would frame something if we regard it as a complication. If we then consider peri-implantitis as a complication, how do we do this? And how do we change this in our mindset? Firm opinion that most cases of peri-implantitis have an iatrogenic etiology. And that was established around the time of the treatment, whether it was the surgery, whether it was the prosthetics, prosthodontics, whether it was the analysis of the patients and the systemic factors and so on and so forth.
Okay, so now we're going to talk about the 8 systems that presented a couple weeks ago. What do most of these implant systems have in common? Blasted neck with threads at or near the top. It's a red circle. There's 2 systems that don't, and that is the Nobel Active. There's some other companies that have a machine surface as well. And this is just showing the Paragon's Gen 5, Gen 5 Plus, and Nizplant, which we'll be talking about, all with a 2 mm anodized machined neck.
And I have to just intervene here. The Southern SP1 implant system also has the machine collar.
Yes, and there are others as well.
Yeah.
None of them, though, have an anodized neck other than Nobel. That was very difficult for us to get FDA approval. We had to prove that our titanium oxide layer was exactly the same thickness as Nobel's in order to have a anodized neck. Then I also added depth gauge lines at 1 and 2 mm, which is patent pending. So it isn't just the smooth neck, although that's good. It's how well you can position it, whether you have vertical flexibility when you're placing the implant. So here are the 10 factors that were discussed, or periods that were discussed. Primary stability and soft bone, probably the #1 issue, because without primary stability, you don't get osseointegration, and you certainly can't do immediate loading. This is dependent on implant taper and surgical protocol, and some of the implants have what it takes to get high initial stability. Armamentarium, this is more a personal choice, so it's not a differentiating factor. Restorative ease, many factors should be considered beyond just the number of implant platforms. It seemed like everybody was saying, oh, one platform, that's how you get restorative ease. That's how you reduce your inventory. We're going to kill that sacred cow. Cost. Yes, they differ from 60 to 600, depending on the implant company and the dentist or DSO's purchasing power. Quality. It's hard to differentiate a quality unless you're looking at it under a microscope, but you can look at the reliance and reliability of the company. Made in America is a good start. Paragon has a 44-year history of high quality products. If I didn't have the highest quality products, you'd see salespeople from every other company running around with SEM pictures of my products, and that's never happened. The new factory that I started in 2022, all new equipment, all the latest technology. Bone maintenance, bone resorption, remodeling is a reality. The question is, what is going to get exposed? Soft tissue health, dictated by avoiding exposure to the implant's threads and rough surface, and a natural emergence profile that facilitates oral hygiene. Inventory management, far more factors than just having one platform, which was stressed by several of the participants. I'll get into that. Customer support cannot be measured by how many outside salespeople in a company. Sales reps often focus much of their attention on the high volume users, leaving the majority unsupported. Restorative connection. Most implants feature conical connections with lead-in bevels ranging from 45 to 83 degrees. The primary issue was stability. The question of how to achieve high initial stability in soft bone was answered in my 2000 article. And also in 1995, I received a patent, and the abstract says, also an implant is given a conical shape. It can be used for supporting artificial teeth in a residual ridge crest of a patient by drilling a smaller than normal cylindrical hole in the crest and carefully inserting the conical implant so that the bone is spread and make additional contact with the implant. So going back to, who invented the conical implant with a soft bone surgical protocol, there it is. There's the patent. And this was a study that showed the higher torque values when you undersize the socket. It's easiest to measure torque by measure stability by torque, and 35 plus Newton centimeters usually gives you adequate stability to consider immediate loading. The 50, 60 Newton centimeters is where I like to end up. And I've yet to see compression necrosis from over torquing. The ratchet will script before that happens. Companies promise high initial stability with their implant designs and surgical protocols. ZimV, Implant Direct, Paragon use a soft bone, hard bone surgical protocol. And this has to be carefully correlated to the diameter of the drills that you're using. A 3.7 implant, you might stop at the 2.8 drill. You might go to the 3.4, 2.8 drill. You may need a crestal bone drill that is 3.7 at the top, depending on the density of the bone. Straumann has a very deep threads claiming high initial stability, and they have bidirectional cutting grooves. It's like a claw that shaves the bone. If you turn it one direction, or if you turn it in the other, it's so sharp that it actually turns. They actually claim it gathers, it cuts, gathers, and condenses bone chips. Well, you can see the bone chips, and they're jammed in between the deep threads, which does not add stability. A compressed bone adds stability. What is the taper of an implant? It's the outside that you pay attention to, because that has to fit into the hole that you created. The inside taper is really irrelevant. It just affects how deep the threads are. Yes, it'll increase the surface area of the threads, but it doesn't push back and compress the bone to increase high stability. It just creates a space for the bone chips to flow into. Nobel's On One has a final shaping drill. And they give you the drill with the implant. The problem is it's lateral cutting. It's not an end cutting spade drill like the other companies use. So if you wiggle your hand a little bit from left to right, you're going to oversize the socket, and that drill may not be the size that you want to place the implant in. If you want to undersize, you get this drill with the implant. If the bone is really dense, they have a couple of other drills, but they don't necessarily have a smaller drill. And then we hear so much about Versailles. An interesting thing you may not be aware of is Nobel 2 days ago announced they bought this company, and this is to condense bone. They turn these drills counterclockwise, pushing the bone out to the periphery. I always thought it's more important to condense the bone between the threads than to push it to the periphery. Now, for those who say I haven't done surgery in years, this should end that controversy. I'm putting in my own implant.
35.
This was 2 weeks ago. Dr. J.B. White assisted me.
Got a millimeter and a half to go. There you go. 60, good. 65. Okay, let me see what we're at.
So I think we got up to 55 or 60, 65, something like that. That's the limit of my participation in the surgery. I just wanted to get the feel of the torque of these new 3.3 Gen 5 implants. 14 millimeters in length. That's the longest implant we make. I don't believe anybody needs a longer implant than that if you have a nice tapered implant that's going to compress bone. Okay, let's talk about Dentsply and Astra Prime Taper implant. It's evenly tapered, should produce good stability, but that's after 30 years of them selling straight implants. So it's about time they improved that. Then we have Dr. Boyce talking on ZimV. Now, ZimV sells the old 3-eye implant, which is straight for halfway down and then tapered a little bit. But they also sell the screw vent, the original screw vent with a 1 millimeter neck. And now they've got Rev 2, Rev 3, Rev 4 that they've added. I saw this post a week ago and I wanted to share it with you. This dentist was cleaning out his cabinet and found this old Center Pulse tray. Center Pulse was who Kofford sold to Calcitech, and Calcitech was bought by Center Pulse. So he's talking about this 20-plus-year-old tapered screw vent with virtually no bone loss. He says, indeed, it was possibly the best implant I've ever had the privilege of working with. I estimate that I placed at least 1,000 of these implants during that formative decade, each one contributing to patients' renewed smile and improved quality of life. So it's very gratifying to see long-term results with my implants. ZimV did a comparison on torque between the tapered screw vent and the Nobel Active with deeper threads, and the TSV, tapered screw vent, exhibited 29% higher insertion torque than the deep threads on the Nobel Active. And that's because the deep threads just create room for the soft bone to push into. ZimV recently introduced 2 more design revisions of the TSV, the TSX, which is basically straight, so they want to follow what everybody else is doing. And then they took the TSV and they carried the acid etched up to the top so it doesn't have the machine neck anymore. Okay, let's talk about the Neodent. The Neodent, let me just see if I can back that up. The Neodent is basically straight with a tapered apex. One of theirs is more tapered than the other. Claims unbeatable flexibility, but it's got no vertical flexibility on placement. That's why they push them so far into the bone, because it's threaded and blasted to the top. No application-specific implant options, which would add to the flexibility, and only one prosthetic platform compromises emergence profile and strength. This is an image produced by Neodent advising that you use these long implants and engage the cortical bone under the floor of the nose. When there's plenty of bone, between these implants, this is showing us how I would have placed and utilized that bone. 6 implants. Yes, you could angle the distal one 15, 20 degrees, and you wouldn't need to buy an angled abutment for that. Angled abutments are at expense, and they're hard to clean for the patient because they create an undercut. So yes, you can engage the cortical bone under the nose if the length of implant that you're choosing does that, but it's not necessary when you have implants that will establish high initial stability. Use of longer implants often dictates the need to angle the implant 30 to 50 degrees just to get the length. So it's the tail wagging the dog. They don't get the stability, so they go to a longer implant. You go to a longer implant, you need to angle it to get room in the bone for that implant. Then you need an angled abutment. So one leads to the other. Here's another case with Neodent implants. You can see how long and straight that implant is. And look at that undercut right here at that angled abutment. And we're going to talk about reducing inventory. Well, when you have to carry angled abutments in 15, 30, 45, 50, 60 degree options, that adds to the inventory. Easily could have put in 6 straight implants with good retention. And this shows side by side the Neodent with the multi-unit abutment and the Gen 5 Plus, which comes with this collar friction fitted onto it. So you're getting half the abutment with the implant. Nice emergence profile versus the offset here. This is straight, this is evenly tapered. These are called buttress threads with the flat facing up. These are called reverse buttress threads, which is preferred for load, stronger metal, and the threads get progressively deeper towards the bottom. And there's a big difference in cost as well, although nobody pays retail for this. But the Neodent with the multi-unit abutment would be $439 versus Paragon at $175. 150 for the implant, 25 for that screw. And this shows the different lengths that the Neodent comes in, 13, 16, 18. The longest implant we make is 14. When you use a long implant like that, you use up a lot of real estate where 2 straight implants could have been placed, providing better support. And the tipped implants bury part of the margin, so you got complications with angled abutments. Okay, here's another video. The question of placing conventional thinking favors subcrestal placement. Paragon provides the option of supracrestal placement.
You know, Oliveira, before this podcast interview, and he was talking about, I still prefer to stay below the bone. He wanted me to ask that question from you. Why are you going against the common knowledge right now?
Well, that's it. I'm taking on the industry with that. Let me tell you why they go subcrestal. Okay. They go subcrestal because the implants have a blasted surface and they don't want it to become exposed to the soft tissue. So they push it down. They bury it a couple millimeters, thinking they're accomplishing something when bone grows over the shoulder. You don't even want the shoulder. The shoulder is there because the implant only has one connection. So the wider implants using the same abutment creates a shoulder, which is a niche. If you lose some tissue of bone, you got an undercut that's hard to clean. If you're going to have a leaking margin, do you want it occurring in the bone or do you want it occurring above the bone? So there's studies that clearly show placing it supracrestal gives you less bone loss than subcrestal. I cite that, I didn't open up the links, but it was in that presentation. There's also shows that you get less stability. If you move it below the cortical bone, like the MegaGen advertises and a lot of dentists do, you've given up the best part of your stability, that cortical bone that's there. And if you want to have a connection that's easy to get to, and also if you go below the bone, you usually need to contour the rest of the ridge. They got drills that go in and open up the opening so you get your flared abutment in. A lot of extra steps that are unnecessary. Just another advantage of a millimeter above the bone is you get soft tissue attachment to that millimeter that is not disrupted when you take off the healing collars and the abutments and the transfers. Nobel has come up with on one. Some of their key opinion leaders said, no, look, we don't want to be chasing this connection down in a deep hole. Let's give us a healing collar we can attach that we can then use as the platform for the abutment. And there's a lot of reasons for that. I just solve all those problems by just sticking it out. I make the implant a millimeter longer. You have having a smooth neck so you can vary the height. And then taking to the next step with a friction fit extender that comes with the implant and can be taken off if we ever need to get back and becomes an abutment. It just makes sense. I think I can convince the profession it's the way to do that.
I think when Steve Ballmer handed the baton to Satya at Microsoft, I read it somewhere, give him one advice: be bold and be right. I think you're involved with that movement, and I'm sure you're going to be right.
Okay, here's a case that was just posted yesterday on Facebook. And I jumped in and told them what I thought was wrong with it. Dentist posted case placing implant 4 millimeter subcrestal and using the new 7 millimeter long healing collar from Nobel and Implant Direct. He asked the question, is it a good depth? One response from a well-known opinion leader said, definitely not too deep because this is a conical, so deep is okay. The bone will recede. There was absolutely no relationship between the conical connection and how deep you can place an implant. I don't understand that one. The bone will recede to the level of the implant abutment junction. That is a fact. You're not going to get integration above it. So if you place it down there, this is what you're going to get. You're going to get dieback to the top of the implant and need a long abutment. You could place the implant where it's level with part of the ridge and maybe exposed a little bit because ridges are usually uneven, or for if aesthetics demands, push it a millimeter deeper, and then you still have room for a nice emergence profile. So stop putting implants subcrestal, certainly not 2, 3, 4 millimeters. Here's the article: subcrestal placement reduces initial stability because of lost contact with crestal bone. I won't read the study, but it's exactly what it says. When 6 millimeter short implants are inserted in a subcrestal position, low primary stability may be yielded, particularly in poor quality bone.
Andy Booster from Bern, Switzerland.
Oh, let me go back here for 1 minute. Let me just bring this guy up here. I lost him. Okay.
Andy Booster from Bern, Switzerland. And I have a big pleasure to be back at the Academy of Osseointegration annual meeting in Washington, D.C. I was invited to lecture about the 4 surgical key factors for successful outcomes with long-term stability. And this is valid for fully, but also for partially edentulous patients. The number 1 key factor is the selection of an implant, and here we have a clear preference today to go for implants with a hybrid surface concept. That means with a machine surface in the transcrestal area.
Notice he said transcrestal. That means starts below the crest and goes through the crest, sticking up. And that's why we have a 2 millimeter anodized neck, smooth neck on the implant. We have drill stops that allow you to place it level with the bone or a millimeter above. And this just shows the various qualities of bone. And in soft bone, you really want to take advantage of that cortical bone. Placing the implant 1 millimeter supracrestal also provides an undisturbed zone of soft tissue attachment. Therefore, transcrestal placement, I believe, to be the optimum position. And this will just give you a preview of Paragon's implants, the Gen 5, the Gen 5 Plus, and the Nizplant. You want to talk about platforms? This one has 2 platforms, color-coded, so it should be easy to match the abutment with the implant. The Gen 5 Plus really converts both of these platforms to a 4.8 millimeter platform that just by adding a screw turns it into a multi-unit abutment. And then the Nizplant is a one-piece implant with a locator platform, but it has internal threads. So you could take that out and now you're left with a multi-unit abutment because it's got a 4.5 degree, and it's got a 45 degree lead-in bevel, internal hex inside. So one implant could be an overdenture. 6 months later, you can come back and do a fixed case on it. Vertical flexibility is achieved by the following design features of Paragon's implants. Each implant was designed with 1 additional millimeter from the standard length. Each implant was designed with a 2 millimeter machined anodized neck. The surgical tray includes drill stops to place the implant level or 1 millimeter. Paragon is the only company to receive FDA approval for placing 1 millimeter supracrestal. Paragon has pending patents on the depth gauge lines on the neck and on the friction fit extender. And this is what we mean by vertical flexibility. You can be level with the bone, you can be a millimeter above, you can be 2 millimeters above, or in uneven ridges, you can be 1 millimeter or half a millimeter in one place and 1.5 millimeters in the other. Now, this 1 millimeter above the ridge is nothing new. The original core bend was always placed 1 millimeter above the ridge, primarily because I was burying the implant and I want to make it easy to find. Here's a 37-year follow-up on core bend. 1 millimeter above the bone at time of placement. Looks like it hasn't lost any bone. These are 32-year follow-ups on 2 implants. The very first screw bend that I did and a core bend on my mother-in-law that lasted 32 years until her passing. Angled abutments add to cost, complexity, and require more diligent oral hygiene. Gen 5 implants achieve stability regardless of the length, minimizing the need for angled abutments. So Dr. Dunlop posted this. It says, for anyone who's interested, this is how it's supposed to look. Well, it's probably the way it does look if you're using a neodent implant that you had to bury 2-3 millimeters subcrest. So you need an angled, a long, skinny angled abutment to get it up there. But really, all we're talking about is the trajectory of the fixation screw. So if you can put it straight and still get a screw tool in to that hole, you don't need the angled abutment. Or you could use an angled screw channel coping and straighten up the abutment in the lab, or use a shorter implant, which will allow you to straighten it up. Southern implants. Depending on the surgical protocol, the evenly tapered implant should have good stability. I'm referring to this one. The other ones seem to have strange shapes to them. Southern's focus is on implants with angled heads. It doesn't make much sense to have to determine and order an implant with a specific angle connection before you place the implant. Norris, depending on the surgical protocol, the evenly tapered implant should have good stability. Sin seems to me that they're primarily straight implants. This one looks a lot like the BLX. But even a straight implant with in the right surgeon's hands, with the right drills, you can achieve a good stability, but it's a lot more difficult and a lot more operator dependent. Nobel claims it is the first company to introduce immediate function. We'll address that question in a minute, but here the primary stability, this is a Nobel replace. Actually, Sargon Moly-Bolt implant was the first to get approval on immediate loading. Zimvi's study, the tapered screw vent was 29% higher torque than the Nobel Active. I showed you that. Nobel Replace does not have a self-tapping groove, and Nobel Active only has a groove that cuts when unscrewing the implant. This groove is counterclockwise. In case the implant gets jammed in, they use counterclockwise to unscrew it. They needed the cutting edge. Self-tapping apex does not provide a stop. If this is cutting at the end, you could drill 13 millimeters, screw your implant in, you could keep on screwing the implant and get into vital structures. It'll cut its way deeper. So it's better to have a rounded end on the implant. Nobel made the following claims under primary stability. I spoke to this. The first one was the Moly-Bolt, and then the first full arch case was done at Harvard as a master's degree thesis using Kofford implants. Dr. Schnittman and his group. The N1 implant replaced parallel. They've got all these different implants, but none of them are self-tapping, except maybe the straight, because you need to have a cutting groove that gets to the major diameter in order for it to be self-tapping. But they still sell bone taps, which I have never made in the last 25, 30 years, a bone tap. So they recommend pre-tapping the bone. Flexible drill protocol. Nobel was just bought Versa, so they're going to change their drilling protocol, I suppose. And active threads just means a sharp end at the bottom, and that could get you into trouble going through the sinus or vital structures. And now Paragon is in production on a implant that's going to be surgically and prosthetically compatible to the Nobel Active, but has 12 different design improvements. Triple lead threads, you can see from the color here, and a patent that was issued to me on bidirectional self-tapping. Self-tapping externally threaded implants includes bidirectional external cutting grooves. So one groove cuts counterclockwise, and two grooves cut clockwise. So say you're putting the implant in, it doesn't fully seat. Instead of taking the implant out and enlarging the hole, you just back the implant a half a turn. It'll shave some bone off and then go back forward. Now this patent was granted over the bidirectional cutting grooves of Straumann because theirs is like a bear claw and it doesn't have a relief area on it for the bone chips. So this patent has been issued and will be incorporated, and we're going to have a full range of diameters of this implants with a Nobel Active 78-degree compatible platform. And this just shows the advantages. I won't get into them now. Let's talk about the Versa drill compression of soft bone. They have a study published, and they said it was possible. Let's see. No significant group difference was found with respect to final insertion torque and implant stability. So this does not help with stability. It pushes the bone to the outside. Bone in contact values were higher for the standard cutting procedures after 14 to 28 days. However, whatever that means, values were similar. Bone after something. it was possible to conclude that the OD technique, that's the Persaud technique, allowed a wider implant bed preparation without prejudice to primary stability. I don't know why you need a wider bed preparation. You just want stability. So this is showing those drills, and you're going to hear a lot of it now. It's going to be at Nobel's booth, and they're going to be trying to sell these drills. Osteodensification, it's not needed with a tapered implant that's self-tapping. In fact, this is an ad of Implant Direct. Now, Implant Direct and Nobel are one and the same now. They joined their sales force. They're owned by the same people. They've been shipping out of Nobel for years. So this oral surgeon gives a testimony. I've been extremely happy with the implant. The threads are aggressive. I get really good primary stability compared to other systems. The stability on the Simply Iconic implant is excellent. Simply Iconic is a legacy implant with a Nobel active connection. So it's the same body basically that I'm using and that the legacy uses. He routinely gets ISQ values of 80 to 90, which is 50 to 60 torque values. So when you get that kind of torque, why do you need to buy drills that reverse compress the bone? Okay, let's talk about BioHorizons. BioHorizons is not evenly tapered. It does not have the reverse buttress threads that it claims. The neck has laser lines and blasting that will contribute to biofilm formation. So they claim the secret, a typical asymmetric thread design used on dental implants and screws, the flat base reverse buttress thread. And he claimed reverse buttress thread, but in fact, they don't have it. A reverse buttress is what we have with the Paragon, flat at the bottom. This is tapered upward. You also see the Paragon implant gets progressively deeper. You don't have that with that implant. 2 millimeter machine neck versus a laser line, and with the laser, the blasted surface and the laser lines, you have a rough surface at the top. Implant design and surgical protocol are essential for initial stability in soft bone. This case shows all on 4 in the maxilla with angled neodent implants engaging the floor of the nose. Typical way they do it. I don't know why they'd angle this implant when they got a socket to follow, but this is showing how I would handle it with 6 straight implants, and in the maxilla, 6 straight implants, staying away from this angling. You see how much bone this mesodistal bone these angled implants take up. You can put 3 implants in that same length. And these angled implants on the lower are unnecessary. This is a clear choice case using neodent. Look at the angle on these implants. Again, trying to engage the cortical bone. These 2 straight ones will also engage the cortical bone. And then he added tuberosity implants. An easier way would be to put 6 implants, short where you needed to be short, longer where you could, and that's less risk, less complications. Complexity is your enemy. Any fool can make something complicated. It's hard to keep it simple. And I took a measurement of these angled implants. One of them was 50 degrees, the other was 55 degrees. And then you got to get an angled head, which is 35 or 40. The screw's still going to come off in this direction. And just one more case like that. 4 implants anterior, could easily put 6 implants. Instead, they choose to use remote retention and a 90-degree angled abutment and a tuberosity when there's plenty of bone here to put 6 implants in. You can see the neodent, the length of the straightness, and this just shows how I would have handled that case. And no need to angle the lower implants. And on the final case, this shows an angled implant that failed, and pretty hard for the patient to clean that angle. Laying a flap, there's the implant that can't be saved, taking the implant out, and then went in with a remote attachment to the zygoma, which is a complicated surgery. When there really was room here to put 2 implants in. I don't know if there's room after that failure, but to begin with, there was. So let's talk about number 2, armamentarium. I'll move quickly. Most systems have adequate surgical trays. This is paragons with drill stops for level or 1 millimeter, and a surgical tray that directs you soft bone up, hard bone to the right, soft bone up, hard bone to the right. Here's my case, which was placed with the surgical guide. After you make the initial pilot hole, you could go just straight to these drills because they're end cutted. They're going to follow the pilot hole drill, but Implant Direct's drills will work with our system, and Implant Direct's keys will work, other keys will work. So we're going to have our own guided surgery kit, but really I prefer just to use guided surgery for the first pilot hole. And here you can see the implants were planned out. Really planned out for the screw hole to come through the occlusal. Now, don't think for a minute that screw-retained single crowns are not a problem. You can have problems with them as well. I'm going to have stock abutments and cemented crowns done on my implants, just as I have on the other implant that I have and on 2 on my wife. When you have a screw-retained single tooth, if the path of insertion of the contacts is different than the path of insertion of the screw, that may not seat. Whereas you screw in an abutment for a cemented crown, you know it's seated, and then you make the restoration. I don't necessarily like holes coming through my restorations. I think it's absolutely essential for full arch restorations, for long bridges, but on single teeth, my favorite is cemented, and that's where having a long neck that sticks 1 millimeter above the bone is an advantage in removing cement, as opposed to working down in a tunnel. You can't clean cement if it gets down in that tunnel, which is why people moved to screw retained, because they were moving to subcrestal placement. Here's 2 Straumann implants placed subcrestal. Here's the crest of the ridge. Here's the implants down here. Now you've got a deep tunnel of soft tissue. And I would much prefer just seating a cemented abutment on top of the Gen 5 implant or on top of the Gen 5 Plus implant. 3 restorative ease. Neodent, Straumann, and others claim that one connection for all implant diameters facilitates restorative ease. What it does is facilitate a poor emergence profile. Now the weakest abutment is going to be used on the widest implant also, and you create this ledge. Straumann recognizes it because they make an abutment that overlaps the bevel, that overlaps the shoulder. They know they need it, so now they make an abutment that sits on the shoulder. If an abutment sits on the shoulder, makes first contact on the shoulder, then the conical connection is not in contact. You're not getting the stability from the conical connection. So here's a narrow abutment, and look at that emergence profile. When they use the wider abutment, it improves it a little bit. But this is what you'd like to have with emergence profile, just like the Straumann tissue level implant, which became so popular because of that emergence profile. So this just compares the emergence profiles. This is the Paragon going across all the diameters versus Neodent versus Straumann. Now, what happens on the wide implant is I do sit on the shoulder, but we made this friction fit. So this extender is friction fitted into the implant. It's seating on the shoulder, and that gives you a nice emergence profile in the molar area. All internal conical connections basically are platform shifting. And somebody would look at this and, oh, well, that's really good. You got platform shifting. All right, let's kill that sacred cow right now. The conclusion of this study, 2010 study, the present randomized clinical trial could not confirm the hypotheses of a reduced peri-implant bone loss and implants restored according to the concept of platform shifting. Where that came from is 3i was having screw loosening with their external hex implants in the late 80s. So they made a 5mm implant thinking it would give them more stability, but they just had the 4mm abutments. So they're putting 4mm abutments on 5mm implants and came up with the story that they'd medialized the junction, and that's why they're getting this bone. They moved the leaky margin of an external hex medial. If you want to think about it, placing an implant 1mm above the bone, we medialized the junction, we verticalized the junction and got it away from the bone. But medializing it, it's the junction is still in the bone. So for those of you that believe in platform switching, this would be a good article to review. And this just shows what the contours look like. This is on a Neodent, and this would be a more ideal contour. You don't want the curve to be in the bone. You want that concavity to be in the soft tissue. Neodent attributes success to one connection and platform shifting. So if you take all 4 slides that Neodent put up, restorative connection, one platform for most implants, platform shifting, soft tissue health, one connection, shifting, inventory management, one platform, cost, one connection. You've reduced the cost because you only have to order abutments of a certain size. They still cost the same, less inventory, less cost. We're going to show you how to save on inventory and cost, and it's nothing to do with one platform. Really, it has to do, one aspect that I've been chasing for years is the search for the ideal one-piece implant for restoring edentulous jaws. If you know that you want a multi-unit abutment on top of the implant, then make a one-piece implant. And I tried it in 97, got a patent issued. 99, I came up with healing collar packaging, which is really the precursor to Nobel's On One. Got a patent issued on that. 2005, I got a patent issued on the screw indirect one-piece implant from Implant Direct, still a very popular implant today. Then I've been working on the Gen 5 Plus, which really is a one-piece implant. When you attach that collar, you friction fit it at the factory. You can't separate it other than with retrieval tool. And then you add screws of different heights to adjust the height. The problem with this implant was you have one fixed height. And here with the neck having score lines, and you can move it up and down a couple millimeters, and with the screws coming in different heights, you have a lot of vertical flexibility. Here's a case, typically with a screw indirect implant, and you see we had to package an extender with the implant because if you needed more height, the extender was there. Then you had to have 2 different colored snap-on transfers to tell the lab whether you use the extender or you use the implant platform. Here's a 10-year follow-up from Dr. Pedro Pena of 5 implants in the symphysis, straight implants. I heard Bronnemark say you could cantilever back to the tonsils. So when I see all these all in 4s with steep angles, I think of this implant. And much easier. You got an extra implant for security and no angled abutments, no abutments at all. And here's a case done by Ed Mills in Atlanta. 6 implants in the top, 5 in the bottom, all the screw indirect implant, beautiful tissue. No worry about a screw coming loose on the abutment. It's all one piece. Let's talk about cost. Implant prices vary dramatically. In 2006, when Implant Direct came to the market, there were premium price companies and discount companies. And I came in at $150 and created the value segment. Today, the major companies are discounting like crazy to DSOs and big users. And they also all own discount companies like Neodent, they have a company in Israel called Bio, I think, something like that. But look at the prices: $609, SimV $555, Straumann BLX $545. You can see the prices. This is downward decreasing. Neodent $289, Brazilian implant. Compared to Paragon, which is going to be a flat, fair trade product, no discounts, at $125. Warren Buffett says price is what you pay, value is what you get. So don't make your decision of what implant to use based on who gave you the biggest discount. Discount off of what? Implant Direct launched online sales of implants in 2006 at 150 when Blockbuster Video had 10,000 stores and Amazon was only selling books. So I was ahead of my time in that regard. It's no discount policy and factory direct prices with all-in-one packaging created the value segment. But look what Neodent is selling for in Brazil. $20. And if you want the wet one, it's $26. $20 to $26 for what they sell for $289 in the United States, and discount to $50 or $60 to DSOs. Also, look at the price of abutments. That can affect it. An angled abutment for cemented restoration from Paragon would be $95 versus $323 from Nobel and $150. And these will fit our new Triactive, but they'll also fit the Nobel as well. Quality for number 5. Paragon has a 44-year legacy of producing high-quality, made-in-America innovative products through my companies. Here's my machine floor in the factory that I built in '94. All new equipment, latest technology. This journal on the industry said Paragon Implant Company, where precision engineering and dental expertise converge. Bone maintenance. Place an implant, subprestal assures bone loss to or below the implant abutment junction. Bone maintenance is essential for soft tissue health. So this just shows implants placed below the crest, and then how you have to try and come up with an abutment to get you through the crest and a funky emergence profile versus putting the implant level with or at the crest. This is what happens when you have implants that are threaded to the top and the thread gets exposed. You have an area that can't be maintained. Here's a case where the bone was up here and the implants were down here, and sure enough, the bone followed it down. Much better to have the implant level with the crest or a millimeter above. 7, soft tissue health. Biofilm forms on rough surfaces, contributing to peri-implantitis. The higher the surface roughness, the higher the mean peri-implantitis rate. This is in a study in 2018. Another thing to pay attention is when you clean or scale an implant, if it's rough, you're going to be knocking off titanium particles, and they show that they get into the soft tissue and cause inflammation, osteoblastic activity. Scaling titanium implants entrails inflammation-induced osteolysis. So you put an implant way down here, you got a problem. Put the implant up, and if 2 millimeters is exposed on the labial because the ridge is narrow there, it doesn't matter if it's smooth. And this shows a Paragon implant level on the labial and millimeters so on the labial. Megagen has finally realized this is a problem with their implant, and now they sell implants with different length smooth necks. So first you have to decide what length of implant you want, then you have to decide what length of smooth neck you want to accommodate this problem. We have it all figured out. Here's a case done by a very good implant dentist in Hartford. Heroic case. Did a beautiful job of bone grafting, but that bone grafting is going to eventually resorb, exposing this rough surface. You're better off if you have a smooth surface that gets exposed. This Swedish Dirks 9-year study found that Straumann implants had the least amount of peri-implantitis compared to the Nobel Active. That was before TiUnite and Astra with their micro threads. About 1/3 as much peri-implantitis with that smooth neck. And Boozer was pushing half of that smooth neck down into the bone. So you had a transcortical smooth surface. This study shows that if you leave an implant a millimeter above the bone, you get less bone loss than if you place it a millimeter below the bone. What's the treatment for a rough exposed surface? Grind it off. This tool grinds off the surface so that you can hopefully get reattachment. Why not just start off with a smooth surface? This is Dr. Michael Norton, past president of the Academy of Osseointegration, was asked to give a presentation on controversies in science. He showed all the implants here, all blasted to the top. Then he showed my implant, and he said, perhaps it is better to have a smooth collar at the top of the implant to avoid biofilm attachment. He also pointed out that these depth gauge notches might act like threads to stop the recession of bone. Okay, inventory management. This is an important one. Dobell has 4 platforms. Our new implant that's coming out will have 2 platforms. Implant Direct's Legacy has 4. Our Gen 5 has 2. You want to reduce the number of components. Don't use a system that requires long implants to get stability. Our longest implant is 14. The Neodent is 13, 16, or 18. And you want to reduce the number of components, place your implants straighter. Otherwise, you're going to need 1, 2, 3, 4, 5 different kinds of angled abutments, especially if you're using tuberosity and zygomatic implants. So you want to reduce inventory, place straight implants a millimeter above the bone. Here's a case done with the Gen 5 Plus. So there's the implant, there's the extender that's friction fitted on. This is the carrier. Place the implants in, then you just attach a screw into it. This is friction fitted. Attach the screw, and now you're done. You got your abutments. So all kinds of abutments available for that 4.8 platform, including locator abutments, healing collar abutments. So here's just the models, placing the implants, attaching the screw, and tightening it down. This is a case done by Dr. Scott Gans. I'm not sure which implant he's using, and it was one of the Korean ones. And this is typical of placing implants in extraction sockets. You're going to have exposed surface, and you're going to be attaching your abutment in a pool of blood. Much better to have the implant up and just attach the screws. And shows all the variations of heights from 2 to 6 millimeters that you can get from the combination of the longer screws and the neck. And this is your entire prosthetic inventory for $25 screws for an all-on-4 case. Here's an upper case done with the Gen 5 implants, not the Gen 5 Plus, just the Gen 5, and then attach the abutments. And the locator system compared to the Nizplant. The Nizplant's a one-piece implant, as I said, with a lead-in bevel, internal threads, internal hex, $135, in contrast to the Zest implant that comes with an abutment. It's really a two-piece implant. You have to screw on the abutment. The inventory here is tremendous because you have to pick the diameter implant, then you have to pick the height of abutment when you're ordering the implant with the abutment. And there's a lot of choices. This plant with a multifunctional platform. Here's the locator. It'll take the locator attachment or abutments that we're making. It'll take an extender if you need more height. Just put in an extender or attach various abutments or an angled screw channel. And look at the height variations just with this one implant. 1, 2, and 3 millimeter tissues, 4 and 5 by adding the extender. Customer support. We only have 10 items. I'm almost done. Customer support. Implant Direct, under my management with a well-trained inside and outside sales force, was rated #1 in support after only 5 years on the market. This was in 2011. A report done by Millennium Research, and we're going to repeat that story with training with inside salespeople and outside salespeople. Restorative connection. We make them both 45 and 78. Really, it doesn't matter because the idea behind a conical abutment is that the abutment is a 1/2 degree flatter than the angle of the implant, so that contact is made at the top, not down at the bottom. So regardless of whether it's 45 degrees or 78, you're only making contact at the top, unless your manufacturing is not as accurate as it should be. And here was a dent implant that they showed in their literature, and you can see the gap at the top, so it's making contact down here. Then there's a new implant called Tri-Implant Matrix, and they do away with the abutment. They say you don't need an abutment, just screw the crown into the implant. So now you've got a butt joint connection and a very short for lateral stability. You got a very big, that's going to make a big hole in your restoration. So I would not recommend that. This is another patent of mine. It says the tubular molar also includes an exterior sidewall portion adapted to form a positional transfer. This was the original patent on a transfer with an index, but also the tubular member has retention means for engaging complementary retention, patent on the friction fit. So this is what a friction fit looks like under high resolution. And here's a case with zygomatic implants. And what happened when the two of them failed? They were replaced with the short bicon implants. So having a short implant is an important part of any implant system. Here's Straumann implant, which is basically straight, the DLX.
And you can see what happened here. So we have cut, collect, condense, and disperse. The tooth will condense the soft bone, and when we have an hard bone, this is going to be cut. So this process is happening 360 degrees all around the implant.
It's not condensing the bone. You can see there's bone chips all over the place. And if you look at the histology, you can see the bone chips next to the implant. It's not compressing the trabecular bone. And it's not a fully tapered implant, it's straight. Okay. These are claims that that Straumann makes for their SL active surface, faster healing time, etc., speed, clinical performance, none of which has ever been proven in any side-by-side comparative. The only thing you can prove is it costs $50 more. And it's because they claim that it gives you a hydrophilic surface. But this study shows the effect of hydrophilic properties on moderately rough surfaces has no impact in terms of biomechanical outcome after a healing period of 2 to 8 weeks. So the minute you put the implant in, the bone, the blood tissue will attach to it, whether it's hydrophilic or not. But it's a good claim to justify a higher fee. After 2, 4, and 8 weeks, implant stability and removal torque was tested, and it was the same. No statistical difference. And a number of companies now have hydrophilic surfaces, claim that it's hydrophilic. This is all based on an animal study that showed a little more of a dip at the 3rd week in retention than when it wasn't hydrophilic. But it was the same at the start and the same after 8 weeks. If you get high torque initially, you're going to load it, so you're not going to worry what's going on at the 3rd or 4th week. So just beware of that gimmick. The surface I've used since 1991 is blasted with HA crystals. And a lot of histology, Brazilian study, LSU study shows that SBM, soluble blast media, was even higher in bone attachment than HA coating, and certainly higher than machines. So that's the surface that I've been using and for years. Okay, this is Professor Leroy Horton did an interview on me and expressed what he liked about our implant system.
I really want to highlight what I love about this implant. Okay, without being too salesy, because I don't want anyone to think that I'm on your payroll or anything, right? But knowing that
Not yet.
not yet. Well, knowing that we might have a discussion, I kind of did a deep dive, and I wanted to see, all right, this man, Dr. Niznick, I see him championing his products, his ideas in comparison to others. And I wanted to see how this would fit in my ideology and practice philosophy. So I love that we have the smooth color, because yes, we are more and more aware that we have to anticipate bone remodeling, and we want to make sure that when it does remodel, there's a favorable surface for the soft tissue to connect to as robustly as possible. And we know that a rough surface is going to catch plaque and promote inflammation. A smooth surface, you're going to get that soft tissue attachment that's going to be a lot more firm. So I love that. I love the anodized gold and pink. So in areas where you might have a thin biotype, gold and pink do very good on our aesthetic scores, right?
And that's for color coding also. So
Oh, yeah.
the 2 colors that you can do that are acceptable are gold and pink. So
Right.
all the abutments that fit the wider ones are pink, and the smaller ones are gold. Down to 2 platforms from 4, but I'll never go to 1 platform. I think that's
a little too simplified there. Yeah. I love that you got gauges on your smooth color, because if you've done implants for any amount of time, whether we're talking about hash marks that you're trying to keep an eye on, when there's a bloody and saline is pouring on your dough, and you're trying to remember, is that the second line or the third line? Or when you're trying to insert your implant, having fixed gauges, I think makes life a lot simpler, right? And if we can make the job of the surgeon easier, that means we're going to improve our accuracy and improve our incomes. I love that.
Let me tell you a funny story about those grooves. Dr. Michael Norton, who was the past president of Academy of Osseointegration, just spoke in Seattle a couple of weeks ago, gave the keynote speech on controversies in implants. And I have been beating him up because all he did was Astra. And he said that he's questioning his confirmation bias. Can all of these implants that are blasted at the top be wrong? Can this one be the right one? He showed mine. And he referred to the grooves. And we know that the bone will run down a smooth surface a little more than it will on a blasted surface. You might lose a quarter of a millimeter more of bone. But he said that those grooves might act like the first thread on an implant and stop the bone loss. So he wants to call it the Norton notch. So that's the Norton notch you're looking at. The Norton notch, it'd be an interesting animal study to see if it does it, but I'm not so concerned about a quarter millimeter of bone loss as I am about complications down the road from peri-implantitis.
Okay, Dr. Norton is a periodontist and a professor of perio at the University in the Northwest. Okay, so now we've gone through all the factors, 6 primary factors that make Paragon implant the best choice. I think actually 7. You got primary stability, evenly tapered with progressively deeper threads assure initial stability. You got restorative ease. Paragon implants are designed by a prosthodontist with 35 patents. Many are the cornerstone of modern implant design, adding vertical flexibility and application-specific implants. Cost, $125 for the Gen 5, $175 for the Gen 5 Plus with the multi-unit abutment, and the Niznick at $135. Quality, 44 years of history. Bone maintenance, Paragon's 2mm machine anodized neck for transcortical placement. Soft tissue health, Paragon's 2mm anodized neck offers vertical flexibility for uneven ridges. Inventory management, stability with short implants minimizes the need for angled abutments and remote anchorage. 2 color-coded platforms simplify abutment selection with good emergence profile. Application-specific implants eliminate or reduce the need for abutments. Vertical flexibility for uneven ridges and reduce inventory of abutment heights. Now, in conclusion, if you want to go to Paragon's website, I've analyzed 12 of major systems, and you can read more about it.
I don't think.
What I want to end is with Gordon Christensen. I gave a lecture to his 250 students at one occasion, and this was his final comment.
I don't think anybody in the world has even a slight knowledge of how influential you have been in the area of dental implants. Nobody has had more patents and more, let's say, analysis of the entire marketplace than you have. I think the idea of having that relatively smooth collar is genius. I think that will allow wherever you put it, you're going to have some integration that you do not get with some of these other brands. He's provided for us today a logical, rational, pragmatic, and inexpensive way to overcome most of the problems you and I have suffered over the years.
Thank you very much for your attention. I appreciate the opportunity and your patience. I went over the hour, but it was a lot of material to cover. Thank you very much.
Well, Dr. Niznick, thank you very much. That was a very comprehensive review and very historical and scientific approach to implant design. So that's very, very neat for us to see it. Just want to let everybody know that the voting on the Implant Faceoff continues through February 14th. So make sure you log on to smartonx.com and vote for the Implant Faceoff representative that you thought represented their implant system best. We should have some Q&A. Cameron, are you available to hop on and guide us through the question and answers?
Yeah, we have one question from Jessica Hurry in the chat. And if anyone else wants to contribute, please do put questions in the Q&A. And it says, many newer implant systems aim to minimize vertical smooth surfaces near the crest and move the IAJ away from bone. Given the evidence that bone tends to remodel away from smooth titanium, clinically, it can be difficult to consistently ensure that the smooth surface of a TL implant system or TL implant remains entirely within soft tissue and does not come into contact with crestal bone. I'd be interested to hear more about the thinking behind incorporating a machined collar and how you see it performing across different clinical scenarios.
Well, I think the whole lecture was covered that, but there was an interesting study that I didn't include. Straumann did a study to try and show that their rough blasted surface lost less bone than Nobel's anodized surface. And when you examine the study, it amounted to 1/4 of a millimeter difference. So there's no doubt that the blast, and that's why I carried the blast and micro threads with the implant direct. This was the thinking. But with the high prevalence of complications of peri-implantitis and wanting to simplify a system where you can have vertical flexibility, it's a trade-off. But 1/4 of a millimeter of bone loss is not going to be your problem. Your problem is going to be a millimeter or two as the bone is chasing that subcrestal implant. And then what happens when that blasted surface gets exposed? So I think that's the answer.
And I think, correct me if I'm wrong, Dr. Niznick, but the blast surface serves two purposes. One is it helps with primary stability, but also it helps with the osteoconductive nature of the titanium to allow for more rapid osseointegration. But machined titanium does not, like the hard tissue does not retreat from the machined surface titanium. It retreats from polished titanium. So, when the original Brandemark implant came out, it was a machined surface and it integrated just fine. It took, the protocol allowed or required 6 months of integration before loading, but the bone did integrate with that machined surface. So it's not a problem to have a machined surface in contact with the bone, which is why it's a problem for polished titanium to be in contact with bone. And your surface is a machined surface, not a polished surface. So is that, do you want to shoot me down?
Yes, thank you. And also, no, well, first of all, the second point about the blasted surface stimulating the bone, I don't know that that's a reality, but it's irrelevant anyways. From the stability standpoint, you've got a 14 millimeter implant with 12 millimeters blasted. That's going to help stability in soft bone, but really compressing the bone, giving you your stability. So everything is a trade-off in implant dentistry. I've been designing implants now for 44 years, and this is about as close as I can get at this point to what I think is going to minimize complications and make it easier to do.
Okay, we got one more.
Any other
Why did you
questions?
name your implant Direct Implant Legacy?
Why? I know who that question's from. Is that from Connor? What happened was that after I sold Corvent and had a non-compete, and then for 5 years, I had to tell them what I was doing in the implant dentistry. They couldn't stop me from preparing to compete, but I had to inform them. So on the last of the day of the 5 years, they sent a representative over, and I had set up to be running clones of the screw vent. And he walked through and he said, "Oh, is that your legacy implant?" And I said, "Great name for an implant." And I called it Legacy, and I always give him credit as for naming my implant. How about, I'm surprised nobody's asking why I'm calling it the Nizplant. I'll tell you why. I started in implants just looking for a solution to stabilize a lower denture. I was the first person to attach a removable prosthesis to freestanding implants. And now it's considered the minimum standard of care. But when I did it, it was heresy in 1982. And I've been looking for the best way to make that solution work. And with this latest version of a one-piece implant, I said, I have to name that after me, because I started with looking for a one-piece or a solution to overdentures.
Well, that's great. Are there any other questions, Cameron?
Nope, that is it.
All right. Well, Dr. Niznick, I do want to thank you for a very educational webinar tonight. And the Paragon system, it looks very intriguing, I got to say. It's something worth taking a look at. You know, I think a lot of people do make you into a caricature that you're, 80 plus years old. You haven't placed an implant since what would you say? 1980. When did you last
Well, I placed this one 2 weeks ago.
Yeah, that's true. That's true. But I mean, the fact of the matter is, a lot of the implant companies are led by people who don't even have a clinical background in the first place. So when you stop seeing patients, I think is irrelevant, so long as you've stayed so long as you've stayed abreast in implant dentistry and you've studied the research and you've had a critical thought process for all of it. When you placed your last implant, when you last saw your last patient, it's irrelevant. It makes you still, I think, more qualified than most people leading implant companies today. So it's been an honor to have you.
I haven't flown an airplane in 15 years, but I still have a pilot's license. So the time doesn't matter. It's what contributions I can make to make it easier and more successful for people doing implants. It can't be taken casually. There's too many complications that need to be avoided. You got to make this as simple as possible and as predictable as possible.
All right. Well, hey, we really appreciate your time tonight.
Thank you. Thank you.
All right. Best of luck with your Paragon endeavors.